Okay, these should go relatively quickly. There's almost no math involved that you need to worry about, so hopefully we'll just draw a couple arrows and we'll get you back to your break as soon as possible. So when we start out with ray diagrams, the first thing we have to do is get a couple definitions. The first definition is going to be, you're going to see this long horizontal line every single time you do a ray diagram. And if they don't give it to you, you need to draw one because it really is kind of necessary. This right here is called the principal axis. And they will refer to it as that on the AP test. That's why I'm telling you that. The principal axis is basically the ground. It's where everything starts. When we put an object on here and everything else, it's kind of like the midpoint, like the equilibrium of a wave. So the principal axis is pretty important, and you're going to find all kinds of interesting things on it. The next thing I want to show you is we're going to be using an object. Now, if you're going to draw something, you can obviously draw anything you want. But just to make it easy, and because it's nice to know, where things are pointed, every time you see an arrow, that's going to be our object. Now, like I said, an object could be a stick figure, it could be a cat, it could be a building, but an arrow is nice and easy because you can tell which way an arrow is pointing because it's an arrow. So whenever you see that, that's going to be our object. Okay, and on the principal axis itself, you're going to see a couple dots. You're going to see one about there usually, and sometimes it'll even have underneath of that a lowercase f, and then twice as far away, you're going to see another dot, and that is going to be labeled C. And I'll get to what they mean in a minute. And then over here on the right somewhere, you're going to see a mirror. Now, don't worry about the type of mirror or anything right now. I'm just putting that there. What the F stands for, some of you may have figured it out, it's the focal point. And the distance between the focal point and the lens or the mirror is called the focal length. You've probably heard both of these before. And then over here, this thing, well, if you look at this mirror is a nice curve. Well, a curve always has a center. And there's an important relationship you should remember, and that is that 2 times the focal length is where the center is. So if you have to draw one of these and they tell you the focal length is 10 centimeters, you know to make your center 20 centimeters away. Okay? So that's basically it for your definitions. Like I said, it'll start making a little more sense. So let's do mirrors. So first thing I want to do is I want to put my object somewhere. I'm going to take this object and I'm going to put it right here for now. And now I've got 3 types of mirrors to choose from. I'm going to get rid of those 2, and I'm going to put a nice plane mirror right here. I'm actually going to make it a little bigger. Okay, so now I've got a nice plane mirror right here. So, we now have an object. Now, when light shines on an object, every single point of that object reflects a light ray. But we don't want to draw an infinite number. That would take a little too long. So what we're going to do is we're going to start all at one point. We're going to start all of our rays from one point, and it's going to be the tip of the arrow. Now, we picked the tip of the arrow because it's the tip of the arrow. It makes the most sense. And we're only going to draw 3 lines. You only ever need 2. I'm going to teach you how to do 3 in case for some reason you aren't able to do 1. The first line that you're going to want to draw, and I'll make it blue for you, goes straight into the mirror. And then, once it goes into the mirror, it's going to reflect backward. Okay? And you're always going to want to put lines with arrows so you remember which one is which. Okay? So on a plane mirror, what you see is that the object, the light goes straight in and the light comes straight back out, which is kind of nice. And just to show you, we're now going to draw a second line here. And for a plane mirror, they're never going to ask you to do a plane mirror. I just kind of want to show you something. You can draw these lines anywhere. So I'll take one right to here. And that is going to reflect out at the same angle it came in. And once again, it's always a good idea to put arrowheads on these things. So you might be looking at this and wondering what's going on. Now what we're looking for is when reflected rays, like this is a reflected ray, this is a reflected ray, when they meet, that's where our object is. Well, if you look, they don't meet over here, but they have to, because where the objects meet, or where those reflected rays meet, that's where the object forms. Well, because this is a mirror, if they don't meet on one side, you simply draw your lines on the other. So what I'm going to do is I'm going to draw some virtual lines here. Let's see here. And let's do this. So this reflected ray, you always draw a virtual line as the reflected ray. You go back into the mirror. Now we're going to do the same thing for this weird orangey color one. And you draw your reflected ray. And what you see is that your lines meet right here. Well, that's where your image appears. Now, because I didn't measure anything out, it should be the same distance away from the mirror. But that's just to give you an idea of how this is going to work. Okay? It may look confusing now, but I swear it's not that bad. So let's do one for real. Let's take my object, and I'm going to put it way out here past the center. And we're going to start with this type of mirror. This is called a concave mirror. Let's actually make this a lot bigger. This is called a concave mirror because it kind of caves in. So there are 3 lines that we're going to draw. There are a total of 3 types of rays. 1, 2, and 3. The first line that you are going to want to draw is going to go in parallel. And now, also, it's a good idea when you draw your ray diagrams, have it go to where the dot is. See the dot right here? Even though the mirror is curved, like up here and down here, just draw it to where the dot would be, so along this line, kind of. Okay? So the first line goes in parallel, and because this kind of caves in, it's going to reflect, and it's going to reflect through the focal point. Okay? And once again, it's not a bad idea to put some arrowheads on these things because it may get confusing. If you have colors, I recommend using them. So there's my first line. In parallel, out through the focal point. The second line does the exact opposite thing. It goes in through the focal point and it bounces out parallel. And once again, toss a couple arrowheads on there. In and out. So there's my second line, which goes in through the focal point and out parallel. And now my third line, it goes, and these might, I mean, your rays might not actually physically hit the mirror. You kind of have to pretend like they do. The third line, this is the line that I don't use very often. The first 2 are good, but sometimes you can't use one of those 2. So the third line, all you do is you draw a line that goes from the tip of the object through the center, and then you kind of pretend that it reflects back on itself. So it comes back, it'll bounce off the mirror if it was down there, and it'll bounce up this way. And don't forget, what you're looking for is where all 3 of these things intersect. And you can see that they all intersect right there at that point. Well, what that means is if I look at a mirror that looks like this, actually here. If I look at a mirror that looks like this and I'm farther away than the center, what I end up with is an arrow with the tip here, the base here. Okay? So what you do is you have to label this image, and you can see it on the sheets that I gave you. You're going to want to label this as inverted, smaller, And then the last one you want to label as, so the first one, it's either inverted or right side up. It's either smaller, bigger, or same size. And then the last one is, you need to tell me where it is. So this would be like between F and C. So if I was going to label this image, I'll label it down here for real. This would be inverted. This would be smaller, because I did have to make the arrow a little bit smaller. And this would be between the focal point and the center. Okay, so you're looking at this and it looks like a mess. We're 10 minutes in. Let's speed it up a little bit and we'll do another picture, okay? So I'm going to do another one of these mirrors, make this a little bigger. There we go. And get rid of that one. And I'm going to put my object now, I'm going to put it, let's put it right here. Okay, so I'm going to go through this one really quickly now, and you'll be able to see how I do. You've got the ability to pause, though. Okay, let's actually do it this way. I'll go a little faster. So my first line goes in parallel, and because it's concave, it reflects through the focal point. It's always a good idea to leave yourself lots of paper, because you never know what's going to happen. Second line comes in the exact opposite way. It comes in through the focal point, and it reflects out parallel. And then my third line kind of goes through the center, but once again, you only need two. Now, you can't really see it because I didn't leave enough room for myself, but you see these two lines right here? They are going to intersect. Remember, it's where the reflected rays intersect. That's why the arrowheads are important. Well, where this thing intersects is going to be way off the left-hand side here. So what am I going to end up with? I'm going to end up with an inverted. I'm going to end up with a much larger, look at the size of that thing compared to the original. And it's going to be past the center. So now, for every concave mirror where the object is in between the center and focal point, I know I'm going to end up with a larger inverted object image past the center. Okay? Let's try another one. So now I'm going to put my object right at the focal point, because something special has to happen there, right? Bigger. Okay. So here we go. Moving right along here. First one goes in parallel and comes out through the focal point. Second one goes in through the focal point, now parallel, but if it can't really go in through the focal point because the object's there. So we're going to go to our third line now. And our third line goes green through the center. Oops. Now it's kind of weird because this is in front of the center, but you kind of do it that, let's see here, that the reflected ray should, see how close I am? Oh, nice. Should pass right through the center. Okay? But what do you notice about these two lines? They're parallel, which means they're never going to meet. And if they never meet, there's never going to be an image formed. The focal point, oddly enough, the place where you think everything would be in focus, there is no image that will form here. And I've got a big concave mirror in my room. If you hold it at about arm's length, your image goes completely blurry. That's the focal length. Okay, let's try another one. Let's keep moving this arrow in here. Now I'm going to put, oops, I'm going to put the arrow here. And this will be the last one for this mirror. The good news is the convex mirror, the next mirror, there's only one type of image that's ever possible. And I'll prove that to you. So for this one, in parallel, out through the focal point. Awesome. Second goes into the focal point out parallel, but you know, I don't feel like going back to the focal point. So I'm going to do the same thing I did before. I'm going to try to line this up so it goes through the center, back behind it. And let's see how close that was this time. pretty close. Now what you see is that the lines are actually diverging. My reflected rays are diverging. You see them over here? Well, that's bad because now they don't meet on the left. What that does mean, though, is something completely new, and that is if I continue this arrow and I continue this arrow, they do meet. They meet on the other side of the mirror. Okay? This something is called a virtual image. And you remember a virtual image is the type that was formed with a plane mirror. It was behind the image. And the definition of a virtual image is one you can't project on a screen. This one, if you look, is going to be larger. It's going to be upright. And it's going to be virtual. The other two that we have done, the rays formed over here. Well, not that one. The rays never formed. This one is actually something called a real image. Because I could actually hold this up and I could project this image onto a screen. This is called a real image. This one right here is also called a real image. Because the lines meet on this side. My basic rule that I tell myself is, if it's a solid line, it's real. If it's a dotted line, it's virtual. Okay, and very quickly I'm going to do this last one. I'm sorry this is turning out to be, I wanted to do a bunch of short ones, but it just didn't make sense. So now I'm going to do a convex mirror. Now, there were lots of different things you could do with the last one, lots of different places you could end up. For this one, the pressure is going to drop a little bit because there's really only one thing you can do. Now, when this arrow comes in parallel, it doesn't meet this focal point. I mean, you can tell by the way, the shape of the mirror, it will not reflect towards the focal point. It won't reflect towards this focal point. It's going to reflect towards this focal point. So what you'll have is there will be another focal point over here, the same distance as the other one, because we need some, it's not because it's really there, we need to have some sort of reference. Let me make sure it's the right distance. So this ray is going to reflect as if it was going to go through this focal point. So that means that it's going to bounce out that way, which gives me a dotted line through there. Now the next line tries to go in through the focal point, that one over there, by the way, and it's going to bounce out parallel. Same rules as last time. But that line's going to continue backward, and it's going to be parallel to the axis, so it's a little off. And you see that these lines, while they don't meet on the left-hand side, they do meet on the right-hand side. And they meet right here. I can't even make it that small. So what I have here is an upright. It's smaller. And because I use dotted lines, it's virtual. Now the cool thing is if you kind of look at this, no matter where you put this object, you're going to end up with a smaller, upright, and virtual object for a diverging lens, no matter where it is. It could be, the arrow could be out here, it could be here, it could be here, it could be anywhere. The object is always going to be upright, smaller, and virtual. All right, that does it for mirrors. That's all kinds of mirrors, and I'll do lenses last, or next, I guess. And the rules are the same, so lenses should be a lot shorter than the mirrors were. All right, I'll see you in the next video.